In this episode, we talk about limecrete and lime ash floors. We also talk about high-level exposed areas of buildings and provide a summary of where we've got to so far in these episodes.
We're now going to look at floor slabs. So, Rich, over to you for floor slabs.
So, what I'm going to talk about the next kind of use of a lime material is on what you walk on in a building, so the floor slab in particular. Now, as many of you are probably aware, most buildings were built with a suspended timber floor, so raised up off the floor to stop any kind of moisture rising up. But actually also quite a few were built with a solid floor because of whether or not that's in a rural location or otherwise. One of the materials that we're talking about, and you may have heard of, is called limecrete. Essentially, it is a great big thick slab of a lime material. So I'm just going to cover off sort of when it's useful, some of the misconceptions about vapor permeability, dense NHL base layers, and then I'm going to look up the design intent and then the moisture management strategy of what you would need to consider if you're going for a solid floor. Solid floors in older buildings were never completely sealed. They actually allowed some moisture to gradually move, which then helped prevent the kind of capillary action in walls, or also known as the rising damp. So when retrofitting or when rebuilding floors, that moisture movement is something that you've still got to manage. And especially even if we're using modern lime technologies that we've got at the moment. So what is limecrete? Essentially, it's not just a slab of lime and sand. It's typically a mix of often NHL or hot lime with a lightweight or capillary active aggregate. So the makeup is a slab of lime and sand, but then below it is also very important as well. And that's often foamed glass or recycled crushed brick or various other things. And that's a very important part of the capillary break from the moisture in the ground not getting to that actual lime slab. So that's often it's got a capillary barrier, which is not a plastic membrane or DPM like you would have with a concrete barrier, but it's foamed glass or geocell. And there's a whole nother podcast we can do on that and the pros and cons of it. But I think there's a really important clarification that I need to make here, which is about what's often a misconception with regard to using a limecrete versus a concrete. That if you use a thick slab of NHL, say 100 mil or so, and actually often you need 100 or 150 mil, the vapor permeability of that is incredibly low. It's actually very close to concrete. So you're not gaining much in terms of the moisture movement characteristics of allowing that moisture to kind of permeate through the limecrete slab to using concrete. And I am aware of some people that are specifying a foamed glass underlay and then a concrete on top because it's that much cheaper. There are other complications with that though, but I recognise. So it's not necessarily the vapor performance of the limecrete that we're talking here. So where are some of the benefits of using a limecrete is to do with the fact that unlike a concrete floor with DPMs, you still have got some capillarity to it. So you still have got, if there is moisture that's going to find its way there, which it naturally will do by capillary action being wicked up the walls, that you're never putting a barrier in place where it can get trapped and then can cause decay and cause issues. And that is the benefit of using a limecrete floor, that you've got a continuity of that pore structure, so that you're never trapping moisture. And that is ultimately how these buildings were built, which is never to put a barrier or stopping things of naturally being able to evaporate away. I don't have any experience and very much knowledge of lime ash floor, which I know when I've gone into buildings, they've got, oh, that looks like concrete to me. That looks like bad. And I'm like, actually, hang on a second. No, it's the lime ash floor, which is perfect. So not limecrete, but lime ash. Tell us about lime ash.
Oh, in fact, you say that, and that's exactly the situation I found myself in many years ago doing a survey in the Midlands, which is actually the area you tend to find lime ash floors. You don't get them over in the east or south so much, and I mean you might come across them, so never say never. But generally speaking, we find them in the Midlands and further north. But I was doing a survey of a building, and I was upstairs, and I pulled back a carpet that happened to be loose, and I saw this grey concrete looking finish, and I thought, oh, that's interesting. It was a bit cracked, and I thought better make a note of that. Took some pictures and put it all back, and I thought, interesting to have a suspended concrete floor in a building like this, because it was a timber cruck frame building from the late medieval period, and I thought, a bit strange. Anyway, I went home, and fortunately, I'm not the sort of surveyor that would churn out a report overnight. It used to take me a lot longer than that. And I thought about it overnight. And the next morning I woke up and I thought, that wasn't concrete, that was lime ash. And I suddenly realised what I'd been looking at. And I did a little bit of research and then did my report accordingly. And I was right, it was lime ash. So what is lime ash? Well, lime ash is, as the term suggests, it's a lime mortar mixed with ash, hence the grey colour, because it is very grey. It does actually look like concrete. And the ash makes it hydraulic. So therefore, we've got something that is actually not far off concrete, both in appearance and to some extent in performance. And the reason the one I saw was cracked up is because it is, again, quite brittle. But I've only ever really come across it in upper floors rather than ground floors. But what you'll find the floor structure with the joists and everything, and then often you'll find reed or woven to form almost like a reinforcement within the floor. And then the lime ash would be poured on top and so on and so forth. And that would be a lime ash floor. Now, if you want to think about a good example of a lime ash floor that has served well and still serves well despite many people walking over it, are the upper floors of Hardwick Hall, owned by the National Trust. Now, they're lime ash. They've served well and still perform very well. So lime ash can last centuries and serve very well. But anyway, so that's lime ash.
Yeah, so I think the only bit left for us to do is the more specific exposed areas. So we're talking about chimney flaunching, copings, that sort of thing. So Stephen, over to you on those bits, please.
Yeah, well, I think this comes back to what we were saying about exposed areas. If you think about it, the most exposed part of a building is going to be the roof, the high level areas, chimneys, gables, parapets, etc., etc., etc. And they're always the bits that are going to need more attention more frequently because they're simply getting battered by weather. So when we think about the mortar we're using, so where might we use mortar? So with a chimney, it's not only the building of the chimney, but the flaunchings. In other words, the slightly angled bits around the chimney pots that cap the top of the chimney. The pointing itself. Then we're thinking about the mortar fillets around the junction between the chimney and the roof, perhaps. The mortar that's bedding the ridge tiles on, or hip tiles that you might have. If you've got a parapet, what about the mortar that's bedding the coping stones or the brick on edge, depending on what you've got there? So it's all these high level areas that will be exposed. Now, as I said earlier, our starting point is with a pure air lime putty, etc., etc. But we know that these are going to be exposed. And whilst you might choose to use air limes, and some purists might say, oh, you've got to use air limes, what you'll probably find is that they fail fairly quickly. Now, if you're up for redoing it every few years, if they fail that frequently, then that's up to you. And that's fine. I'm not going to say anything other than that. Good on you. But it's your pocket, your time, and having to keep on top of it. However, if we go to the other extreme and say, well, in that case, why don't we use cement? Well, cement's a bit too brittle. So what you'll often find, especially if you use it between the chimney and the roof on those fillets or flaunchings or what have you around that junction, they will crack. And once they crack, they let water in. So you get leaks around the chimneys. What about if you use it around the chimney pots at the top? Well, again, it cracks, lets water in. You get water down the chimney. So cement isn't ideal for those situations. So what is? I've just said that air lime is too soft and not resistant enough. Cement's too brittle and is going to cause problems. So what are we going to use? Well, the answer is something in the middle. So then we get back to our naturally hydraulic limes or a mix with pozzolans added or something like that to make it hydraulic. And that way we get a quicker set, we get a better weather resistance, but it's not so hard that you don't have a bit of flexibility. You still need a bit of flexibility. So what would I use? Well, I probably wouldn't use an NHL2. I think that's still a bit too feeble, a bit too soft. I'd probably try 3.5. That would be my preference. But certainly for flaunchings around chimneys, I'd probably go with 5 because I want that weathering. And let's face it, to get up there, you've got to get scaffold and the cost and what have you. So I'd go with 5. And could it crack? It could, but it's less likely than a cement. So I'd go with a 5 for things like that. Ridge pointing, a 3.5 or a 5 maybe. Flaunchings around chimney to roof, again 3.55. And also, if you incorporate the slips of slate or tile into that mortar bed, that helps. Not only with the protection, it stops some of the cracking as well. That it is a useful thing, not just to have a pure mortar flaunching. So I hope that helps. And I'm not saying every situation is the same, but it is thinking very carefully about the exposure and what might suit in that circumstance.
I was just going to add in then, one of the things we haven't mentioned in the previous videos is the time taken to set. Now, whether that's by carbonation or by hydration, clearly the thicker the mortar is, the longer it takes to set. And anecdotally, I believe, for a air lime, you're talking around an inch a month for it to carbonize in carbon dioxide. So if you've got a great big blob of air lime on a flaunching of a chimney, potentially the bit at the very bottom may never carbonize fully, essentially, because it's carbonized from the outside, so you won't get any carbon dioxide to it, but also it takes such a long time. So that's why you would need a more hydraulic set on that area, because otherwise great big blob of mortar will just take forever and may not ever properly go off or set appropriately. I thought it was worth adding in.
Well, yeah, and actually the thickness is quite important. If you're dealing with the exterior, it's going to carbonate from the outside. As Rich has just said, you stand at risk of the inner surfaces never carbonating. So what you need to do is build it up in layers and put a backing coat on first. And then your scratch coat, then a finish coat, sometimes 2-3 coats, it depends. But the real skill is knowing when that backing coat has started to carbonate, but not so far gone that you can't now put another layer on, but it's gone far enough that if you put another layer on, it's going to carry on. And by the time it's finished, that all of that thickness has carbonated to the same degree. That's where the real skill comes in. So yeah, thickness is important. Okay, so we've talked about a lot of different things, and hopefully that's been very helpful. But just to recap, the important thing here is to match the lime you're using to the situation you're facing. Although we might say that we start with the air lime as our baseline usage, that might not always be appropriate because it hasn't got the weathering characteristics we need, or so on and so forth. On the other hand, we need to think very carefully if we're going to use NHL, naturally hydraulic lime, simply because it might set too quickly, it might set too strong, etc., etc. And also at the cement end of the scale, are we going to use cement? If we are, what are we going to use it for? As I say, the Victorians did, and sometimes that worked fine, but in other circumstances it didn't work fine. So we have to think very carefully. The thing is that the strength of the material is not a reliable guide to what's appropriate. As I mentioned earlier when talking about pointing, lime mortar as a pointing can actually be very soft, to the point you can get your fingernail and score it. You can get a key and pull it out with that. That doesn't mean to say there's a problem with it, because it's the right material in the right circumstance. But would we want that on a render? Would we want to be able to, in an exposed location with a render, would you want something that is that soft it will just simply crumble away? Because if we have a heavy rainstorm, could that actually cause some damage to it? So we need to think very carefully when we're using lime to match the right lime to the circumstances, the job we're dealing with. And we can use the past to guide us. Now, we can use the past to think, what did they do that worked? What materials they used that worked? And bear in mind, we've talked about all the hybrids and the things that they've used, particularly through the Victorian Edwardian period. But also, what did they use that failed? The Macintosh example I mentioned, that didn't work. And perhaps we've used examples in the past that have failed. So you might find something on your building where something has been used in the past and it has failed, and you know that wasn't the right thing to do. So use past examples, past mistakes to help guide you. Think about the actual exposure. Are you inside, outside? Are you sheltered? Are you exposed? The vapor permeability of a plaster on a ceiling is far, far less important than on an external wall. So, what are we doing here? What are we using it for? What is the substrate? Are we on timber? Are we on brick? Are we on a mixture? Are we on earth, for example? How soft, how movable is it? Is it going to flex and move with temperature or moisture changes in the atmosphere? Because we need to allow for that. We need a more flexible finish if it's a flexible substrate. Do we need early strength or not? Do we need flexibility or not? How reversible do we want it to be? And sometimes we have to think about what has happened in that building in the past. As a quick example of that, I've dealt with a number of converted stables over the years. And what I found is people forget that horses urinate. And urine is a prime source of salt. And so what you find in these stables is the walls have absorbed a material that is salt laden. And when it is then converted and covered up, and you then apply heat to it, and maybe some moisture happens from whatever reason, that salt comes out and causes no end of problems. And converted stables can be a bit of a nightmare to use. So you have to think about, what are we putting it on? Is that substrate, has it got something, a chimney, for example? I've said slaves, what about a chimney? Flue gases go up a chimney. They let out chemicals that leach into the brickwork and eventually leach into the room. That can damage plaster, it can stain it. So what are we putting it over? What are we trying to cover up with our plaster, pointing, whatever? So those are the sort of things that we're thinking about. Obviously, historical accuracy is very, very important. And obviously, the older the building is, the more important the building is, the significance of the building is key. However, we also need to think about actual performance. And what does that mean? So I'm very much taking a pragmatic view. So historic accuracy, but with a bit of pragmatism thrown in. Hopefully that's helpful. So to conclude this podcast, over to Rich.
Thank you, Stephen. Well, I think hopefully the series of these episodes specifically about lime have been really helpful and sort of painted a picture in terms of both the chemistry and in terms of how they're formed and what they are, the differences between the different types of lime, and then now this episode on the applications of those and where you can often find them in buildings and what the considerations are. But I think the important thing to remember is that choosing the right lime is not just a technical decision. It's actually critical to the long-term health of the building and also the occupants. As we mentioned before about mold growth, I mean, it's actually not just the building's health here. We're talking about people that are living in it as well. I mean, if you get it wrong, you do risk trapping moisture, and that does risk damaging the fabric of the building and actually undoing the years of heritage and the reason why we treasure these old buildings in the first place. We did mention it throughout the podcast, but a general rule of thumb would be the least harm, or at least the least potential for trapping moisture, would be to use an air lime. So a non-hydraulic lime, so a lime putty, for example. Because the worst case scenario there, in most cases, would be that you've just wasted your time and money. Now, it's quite a lot of money and time because, of course, getting a lime plaster to put plaster a wall if it's the wrong type of thing is expensive. But at least you're not then going to be trapping moisture, which could then cause either brick spalling or cause other issues. So at least you're giving the vapor and the moisture the perfect opportunity to evaporate. So that's the least time of using an air lime. But there really is not a one size fits all. So it is all about, and hopefully what we've been covering throughout this is about understanding the context, the substrate, and all the other factors that go into picking the right material for your particular building. So if you're unsure, it is really worth consulting someone who knows about traditional materials. And what someone's stuck on a Facebook group about this particular application does not necessarily mean it's right for your application. It has got to be a bespoke understanding of what's going on with your building, your scenario. Even how you use the building will make a difference in terms of what is the right material. So understand the building, the materials, the environment, how it was meant to function. And plug here, that's one of the reasons why we've set up Expertable. So you've got someone that's not got a vested interest in trying to do the work for you, but you've got someone just like Stephen or just like Ben Kurzake we mentioned before, who are Expertables on the platform, that you can have a conversation with about, I've got this situation, I've got these options, what's best for my scenario, please? And you can book a one-on-one consultation via video with doing that. Anyway, that's enough of the plug. Hope you've enjoyed this episode. Please do subscribe to this particular channel. It helps us understand that we're doing the right thing. Stick us a comment in terms of if you've enjoyed it or if you'd like us to cover certain other topics. And the thumbs up and the likes also helps boost the algorithm, say this is the kind of video that people want to go and see. So stick all that down here, please. That would be very helpful. Thank you ever so much for listening or watching wherever you are. Really appreciate it and look forward to seeing you next time.
In these last couple of episodes, we've been talking about lime, and Rich has had a great opportunity to geek out on the science. So hopefully you've enjoyed all that. But what we're going to be doing next is having a discussion with other professionals and those involved in conservation projects, because there are differing views, and it is important that we look at all the different points of view and the different pros and cons about using different limes. We've yet to record it, so watch out for it. So if you want to be reminded, don't forget to subscribe and press that like button. Thanks very much. See you again soon. You've been listening to Talking Conservation,
The podcast all about conservation of old, traditional and historic buildings and sites.
with me, Stephen Boniface.
And me, Rich Aylesbury.